One of the greatest riddles the universe baffles us with is why there is so much more matter than antimatter. The thing is, according to the laws of physics, you can create and destroy matter and antimatter only in equal amounts. But when we look at stars, galaxies, and other large-scale space objects, we see that all of them are made of matter. Only small traces of antimatter can be detected in the cosmos. So the question is, could an equal volume of antimatter exist somewhere? Maybe at one point it just got separated from regular matter? And if it's so, could black holes be that place that contains all the lost antimatter in the universe? If the total mass of supermassive black holes was approximately the same as the amount of that missing antimatter, it could really be the answer. So let's try to figure it out together. At first sight, it may seem that the universe isn't homogeneous and galaxies clump and group together. But if you look at it on a very large scale, you'll understand that the universe has the same properties everywhere. If there was a galaxy made out of antimatter instead of regular matter, we would spot a great number of matter-antimatter annihilation signatures. But since we don't see them anywhere, not in clusters of galaxies, not in individual ones, and not even in colliding clusters of galaxies, we can conclude that almost 100% of the universe is matter. But this is kind of confusing because, according to the current laws of physics, there are no mechanisms that can create more matter than antimatter. Let's take quarks, elementary particles that are building blocks of all visible matter in the universe. Every time we create a quark, an antiquark also forms. And when a quark is destroyed, an antiquark stops existing too. The only way to create more or less matter is to make equally more or less antimatter. The only seemingly logical explanation can be that in the universe's past, more matter than antimatter was created. In the standard Big Bang picture, when the universe was in its early stages, particle-antiparticle pairs of all known and yet to be discovered particles appeared in tremendous abundance. All because at high temperatures and densities, new particles-antiparticles can be produced spontaneously from pure energy. Then these pairs annihilate, producing pure energy photons again. When the universe cools down, it runs out of energy to create new pairs, and the annihilation process becomes prevailing. But what if, at one point in the early universe, something made antimatter collapse into black holes while leaving regular matter behind? After all, we have discovered quite a few ancient supermassive black holes. But then, there's a theory of direct collapse. According to it, some black holes don't need stars to run out of their space fuel and go supernova. Instead, they simply collapse. This process could create seeds, large and fast enough to grow into the young quasars we see today. According to some theories, quasars contain massive black holes. So we can most likely rule out supermassive black holes. But there are also hypothetical primordial black holes. They're often viewed as candidates for dark matter. These holes, if they exist, can't be too light, otherwise they'd have decayed. Neither can they be too heavy. This way, we'd have already spotted them. So most of the possible mass ranges allowing for primordial black holes to be the missing antimatter are already ruled out or very tightly constrained. But in any case, astronomers have managed to estimate the total mass of all black holes in the universe, and it turns out to be approximately 0.007% of the total energy in the universe. And given that there's around 700 times as much normal matter as there are black holes, we can make a disappointing conclusion. Black holes can't be where antimatter is hiding. Neither can antimatter form black holes. The universe somehow managed to make more matter than antimatter at some point in the past. That's actually why we appeared in the first place. But how exactly it happened still remains one of the biggest mysteries in physics today. How about I tell you that aliens might exist? I know it probably goes against everything you believe in, but it's a new model of the universe that could explain how intelligent life spreads and distributes. This model makes lots of predictions. For example, we should expect to meet another civilization at some point. It also mentions our chances of starting to get messages from aliens, or even becoming an interplanetary civilization ourselves. This model also explains why we haven't met other space civilizations yet, considering the huge number of stars and galaxies in the universe. But let's go into detail. The main assumption of the model is that, at one point, a civilization existing in the vastness of the cosmos can become Grabby. You see, there are two types of civilizations. Quiet aliens don't actually try to expand. Neither do they change much. And after some time, they just disappear. That might be the reason why we don't have any data about them. And all that is left to do is to make speculations about their existence. But there are also loud aliens. They supposedly keep spreading really fast until they meet other space civilizations. The model also calls these loud aliens Grabby. That's because they expand from their home planet at a fraction of the speed of light. They also make significant and visible changes wherever they travel, and they last for a really long time too. Why might we suppose that Grabby aliens exist? Because their existence may be the most plausible explanation for why humanity appeared so early in the history of the universe. See for yourself. The current date is 13.8 billion years after the Big Bang. Small stars can burn their cosmic fuel for up to 1 trillion years. And according to the standard model of the origin of advanced life, it's more likely to appear at the end of the longest planet lifetimes. Well, Grabby aliens might be to blame for our early appearance. Such civilizations could set deadlines for others. If such aliens indeed exist, they will occupy most of the observable universe really soon. And when they succeed, no other civilizations will be able to appear, because all the habitable planets will already be taken. A civilization like ours, advanced but not Grabby yet, could only appear early, because later it wouldn't have a chance to do it. There's another reason why the idea of Grabby aliens seems plausible. Look at life on Earth, like humans. Aren't we Grabby in many ways too? Species, cultures, and companies tend to expand and occupy new niches and territories as fast as they can. For example, species spreading on new territories get access to new resources, and thus increase their population. Why shouldn't we expect the same behavior from extraterrestrial civilizations? The main author of this model, Robin Hanson, was also the first to introduce the idea of the Great Filter in 1996. According to the Great Filter theory, the universe is filled with countless life forms, but people haven't stumbled across any of them yet because somewhere there is a Great Filter. The main purpose of this filter is to stop and finish those civilizations that advance to the level of star colonization. Suppose that this idea is true. There are 3 possible scenarios for our civilization. The first one: we're unique because we have passed the Great Filter. Other civilizations haven't managed to make it this far. The second scenario goes like this. We're among the first potential colonizers, before the conditions in space were too harsh for life forms to leave their home planets. In this case, chances are high that we'll soon encounter other civilizations. And the third scenario is quite worrying. We haven't reached the level of technological development that is advanced enough for the filter to locate us. This means that we haven't passed the filter yet. In other words, the trial is still ahead, and it's a big question if we manage to pass it. Time runs like a river. It has direction, always advancing. It has a certain duration, periods between events you can measure. Time feels real, always there, unstoppable, moving forward. But what if I told you that time might not exist? Some physicists and philosophers claim that there might be no such concept as time, and we should take this possibility of the non-existence of time seriously. You see, recently physics has been in crisis. For the past century or so, 2 extremely successful physical theories have been used to explain the universe. Those are the theory of general relativity and quantum mechanics. Quantum mechanics describes how things work in the super tiny world of particles and their interactions. As for general relativity, it provides an outlook on the bigger picture, for example, gravity or how objects move in space. And even though both of these theories seem to be working really well, They are believed to conflict with one another. That's why some scientists think that they need to be replaced with a new, more general theory, like quantum gravity. This idea might be able to explain how gravity works at the miniature scale of particles. Apparently, it's incredibly difficult to produce the theory of quantum gravity, but it might be possible to do it with the help of string theory. It replaces particles with strings, vibrating in 11 dimensions. But there's one problem. Even though string theories do provide several models describing the universe, they don't make any clear predictions that can be tested by experiments to understand which model is the correct one. There's one more idea known as loop quantum gravity. According to it, the fabric of space and time is made of super tiny chunks, loops. But the most remarkable aspect of this theory is that it completely eliminates the concept of time. Now suppose this idea turns out to be correct. Will it mean that time doesn't exist? Well, the answer is kinda complicated. Everything depends on what the word exist means. A philosophy professor from Cambridge University claims that the three basic properties of time, a present moment that is special, the flow of time, and its direction, come from our mental states and not from the physical world. So we sense this arrow of time because our minds add a certain subjective ingredient to reality. At the same time, Einstein's theory of relativity supports the idea of the block universe, a four-dimensional space-time structure where time is like space. It has its own coordinates in space-time. Time is tenseless there. Thus, the future and past are as real as the present. Does it mean we're being fooled by our human perspectives? Is the feeling that time passes and has a certain direction false? Well, we can imagine our world as a three-dimensional place where stuff happens gradually over time. Or it might be a four-dimensional space where nothing actually happens because nothing changes. It's all here at the same time, past, present, and future. The main idea of relativity is that there's no absolute space and no absolute time. Everything is relative. Trying to think about time in the context of the universe, you realize that you need to isolate part of it and call it, let's say, your watch. And time is basically the relationship between some parts of the universe and that thing you called your watch. Another scientist says that time is just a collection of snapshots describing our reality while continuously changing one into another. Here, you hit play. Here, you're blinking while watching this video. And here, you're taking a sip of your coffee. Without these changes, there wouldn't be any notion of time. The changes are real, but time is not. Our brain sees these changes and constructs a sense of time, believing that it's flowing. What do you think? Is time just a social construct, or does it really exist? Have you heard of quantum immortality? These days, many people are confused about this notion. But if you believe in it, you also believe that you can live forever. How come? Well, quantum immortality claims that nobody ever disappears forever, and that consciousness never passes away. Instead, once you cease to exist in one universe, your consciousness simply gets transferred to a parallel universe, and there, you survive. This idea sounds more like a sci-fi movie than something that real science can suggest. It could be a script for a blockbuster. People's consciousness can transfer from one world, where an apocalyptic event has wiped out all life, to another, where such an event has never occurred. And the only clues about the slight differences between these worlds are a few Mandela effects. This phenomenon is named after people disremembering Nelson Mandela's passing. These days, the term is used to refer to any collective false memories. So maybe in that new world, millions of people will be wondering, since when has Pizza Hut been written with 2 T's? But the thing is, in this new reality, this popular brand name has always had 2 of them. Imagine going through apocalypse after apocalypse, transferring to one world after another. It might be a nice, if a bit horrifying, thought that you're going to live forever. Instead of passing away completely, you'll just keep transferring to a universe where nothing tragic has happened to you. But is there anything to this theory? What does science think about such a possibility? In fact, the idea of quantum immortality has been around for quite some time. It has been seen both as untestable nonsense and as a curious thought experiment, like the one involving a cat. And here, I mean Schrödinger's cat. Let me explain. According to one of the interpretations of quantum mechanics, particles can exist in several states at the same time. But when a particle is being observed or measured, this system collapses. As a result, the particle is found in just one of its possible states. In 1933, Schrödinger suggested doing a certain thought experiment. He believed it would show the absurdity of this idea. In his hypothetical scenario, a cat was placed inside a box with radioactive materials. These substances had a 50-50 chance of decaying over an hour. If it happened, the radioactivity would be detected by a Geiger counter, which, in this case, would smash a vial with poison. As you might assume, it wouldn't end well for the cat. Schrödinger saw the following problem. The cat in the box would be both alive and not alive at the same time. The animal would be in this state for an hour, until someone opened the box and checked on the feline, either lifeless or very annoyed. One solution to this problem, known as the many worlds interpretation, gets around this situation by claiming that both outcomes take place. According to this hypothesis, all possible outcomes of quantum measurements occur across many universes, and their number might be infinite. It probably doesn't come as a surprise that this theory is often criticized. Many mention that this idea is unfalsifiable, since universes don't interact with one another, making the theory impossible to test. It's even been called one of the most implausible and unrealistic ideas ever. After all, it's not clear why your consciousness would get transferred between worlds just because you cease to exist in one of them. Unless it's a thought experiment, of course. It might provide you with the comfort of knowing that there is another you who doesn't pass away in a different world. But why should you believe that you only exist in the world where you're alive? What about the universe where you didn't make it? Like, what happens to your body? And speaking of the suggestion that you might understand that you're in a different universe thanks to Mandela effects, it's kind of the area of science fiction. This tool is always available, 24/7. It improves your accuracy and reduces the number of errors. It can perform boring and repetitive tasks instead of you. You've probably guessed that I'm talking about artificial intelligence. But what if I also told you that it has the potential to make humanity disappear? Leading computer scientists and technologists are worried. They believe AI poses a risk of extinction to our civilization. And it's so serious that the situation calls for global action. Experts claim that super-powerful AI systems can only be developed after we become confident that their effects will be positive and risks manageable. AI is advancing so fast these days that it has raised concerns about the potential negative consequences of such rapid development. They might range from mass job losses and copyright infringements to instability in different spheres and the spread of misinformation. There are also those who are afraid that people will one day lose control of the technology altogether. The thing is, current AI has yet to achieve AGI, which stands for Artificial General Intelligence. But once it reaches this stage, it will potentially be able to make independent decisions. And doesn't it sound truly terrifying? But the most alarming thing, researchers at Microsoft say that GPT-4 has shown sparks of AGI. It turned out to be capable of solving difficult tasks spanning math, coding, medicine, psychology, law, and many other fields. And it didn't need any particular prompting while doing this. So, are we on the road to superintelligence? And why are most people not worried about it? It might be because we are confused about the very term AI. Most people associate AI with sci-fi movies and don't realize it's our reality now. Nowadays, AI is a broad topic. It ranges from our smartphones to self-driving cars to something that can change our future dramatically and irrevocably. Let's clear things up. we should stop thinking of AI as robots. A robot is just a container for AI. Sometimes they might mimic the human form, sometimes they don't. But AI itself is inside. AI is the brain, not the body, if it has any. Have you ever used, let's say, Siri? I bet if you're an iPhone owner, you have. So Siri is an AI, and the voice you hear is a personification of that AI. And guess what? There's no robot involved whatsoever. Now, back to the dangers AI might present. There's a chance that soon, AI chatbots will become more intelligent than humans. And then, AI may start, or be used, to generate misinformation capable of destabilizing society. In the worst-case scenario, however unrealistic it may sound, machines might become so intelligent that they will take over the world, which would lead to the extinction of humankind. There are other, no less pressing concerns. For example, AI could start playing a big role in making decisions affecting our lives. Imagine people becoming so dependent on AI that they can't live without its advice and guidance. They rely on it in all spheres of their lives, from buying groceries to choosing a vacation destination to picking a name for their child. Sounds scary, doesn't it? Lots of jobs, more than 300 million all over the world, will be, and already are, at risk because of AI. It happens as certain tasks and job functions become automated. This tendency might also affect administrative jobs, the legal sphere, architecture, management, and more. At the same time, we must acknowledge that AI is beneficial for many sectors. Experts predict a 7% increase in global GDP thanks to it. For example, some areas of science and medicine are already taking advantage of AI, developing new medicines and treating some diseases. For the time being, countries are trying to pass special AI-related legislation. It's supposed to classify AI into 4 risk-based categories, deal with fakes, and make companies register their algorithms with regulators.